Welcome to the Explainer. Today we're going to completely demystify two of the most essential, yet, let's be honest, frequently intimidating tools in all of modern software development, Git and GitHub. Whether you're stepping into a role as a software dev, a data scientist, a DevOps engineer, or even a technical project manager, mastering these platforms is absolutely non-negotiable. I mean, nearly every modern software project relies on them. So we're going to break them down step by step to give you a really clear structural understanding of how they work and why they're just so powerful. Okay, let's dive into this. Here's our roadmap for today. 1. The version control problem. 2. Git versus GitHub explained. 3. The 4-stage workflow. 4. Branching and conflicts. 5. Collaborating in the cloud. And finally, 6. Real-world best practices. All right, kicking things off with Section 1, the version control problem. So to really appreciate the elegant solution of Git, we first have to ground ourselves in a universally frustrating experience. Think back for a second. Have you ever been working on an important document, maybe an essay or a big presentation, and found yourself saving a file as final_v2? We've all been there, right? You make a change, you definitely don't want to lose the old version, so you just hit Save As and tack another word onto the title. Before long, your folder looks exactly like this. You've got book_v1, book_v2, book_v3_final, then the inevitable final_final, and the completely desperate really_final. Without a proper version control system, absolute chaos ensues. Eventually, nobody knows which file is actually the latest, what changed between version 2 and 3, or who even made those changes. Version control exists to permanently eliminate this nightmare. It meticulously records every single change, who made it, when it happened, and why, giving you the incredible power to restore any previous version at literally any time. Moving right along to Section 2, Git versus GitHub explained. These tools are basically the heroic solutions to our file naming nightmare. But a super common beginner mistake is thinking they're the exact same thing. They're actually two very different tools that just work closely together. First, let's define Git. Git is a distributed version control system created by Linus Torvalds back in 2005. The real magic of Git is that instead of saving multiple messy copies of a file, it securely tracks every single change over time. It effectively takes a snapshot of your entire project at specific moments. This lets you track changes, undo mistakes, and create experimental features totally safely, knowing you can always revert back to an older snapshot. And this brilliantly illustrates the relationship between the two. If Git is the engine, well, GitHub is the destination. Think of Git kind of like Microsoft Word. It's the local software running right on your own computer where you do the actual work. GitHub, on the other hand, is like Google Drive. It's the cloud hosting platform on the internet where you store those Git repositories so you can back them up and actually collaborate with your team. When we compare the two side by side, the boundaries become really clear. Git is the underlying version control software. GitHub is the cloud hosting service. Git lives and runs completely locally on your computer. GitHub runs up on the internet. And while Git is primarily operated through text commands and a command line tool, GitHub gives you this rich, visual web application interface. Now, you don't actually need GitHub to use Git, but in modern development, combining them is 100% the industry standard. Okay, Section 3, the 4-stage workflow. To use these tools effectively, you've got to understand how Git actually moves your files around on your local machine. Think of it like a strict assembly line. Here's the core Git workflow sequenced as a literal step-by-step process. First, you have your working directory. That's just a folder on your computer where you're actively typing and editing files. When you're ready to bundle some changes together, you move them to the staging area. Once staged, you lock them into your local repository as an official snapshot. And finally, you push that local snapshot up to the cloud, right into the GitHub repository. As your files move through that assembly line, Git categorizes them into 4 specific states. A file starts as untracked if Git has never seen it before. Once you edit a file Git already knows about, it becomes modified. Then, using a command called git add, you move it to the staged state, prepping it for a snapshot. And finally, using git commit, the file becomes committed, safely stored in Git's history. It's a highly organized, very intentional process. Next up, Section 4, branching and conflicts. In the real world, you've often got multiple people working on the exact same project at the exact same time. The source text defines a branch simply as an independent line of development. I actually like to think of branching as the absolute superpower of Git. It gives you the ability to create a completely safe sandbox. You can copy the main code, experiment, break things, try crazy new ideas, all without ever affecting the actual live version of the project. The golden rule here is to keep your main branch stable. You do this by creating a specific feature branch for every single task. So if you're building a new login page, you branch off and literally name it feature-login. If you're fixing a typo, you create a completely isolated bug fix branch. This keeps everything beautifully organized and ensures your main codebase is always in working order. Eventually, though, you have to bring all those branches back together into the main code, a process called merging. Most of the time, you get a clean merge, where Git is incredibly smart and just automatically combines the branches for you. But sometimes, you run into the dreaded merge conflict. This simply means two developers modified the exact same line of code in different branches, and Git basically throws its hands up because it doesn't know whose version to keep. It pauses the whole process because it requires manual human intervention to resolve the conflict and decide which code wins. All right, Section 5, Collaborating in the Cloud. This is where we transition from working alone in our local terminal to teaming up with developers all over the internet. Let's move to Git and see how this builds into the famous pull request workflow. A pull request, or PR, is essentially a formal request to merge your isolated branch back into the main code. The workflow looks like this. You create your branch, commit your changes locally, and then push that branch up to GitHub. Then you open a pull request. This alerts your team that your code is ready for review. They'll look it over, leave comments, and once it's approved, the code is officially merged. It acts as an absolutely crucial quality control checkpoint. But, GitHub isn't just about code storage. It's a full-on project management suite. It features GitHub issues, which let teams track bugs, assign tasks, and plan feature improvements. It also includes GitHub projects, which provide agile Kanban boards. You can visually move your work tickets from to-do to in progress over to review and finally to done. This really elevates GitHub into an incredible hub for overall team collaboration. And finally, Section 6, Real-World Best Practices. Let's bring everything we've learned together into a cohesive, practical view of how professionals actually work. So, the crucial point is synthesizing all these isolated commands into a single practical workday. If you're a software developer, your chronological routine looks exactly like this list. First, you pull the latest changes from the cloud to make sure your local machine is completely up to date. Second, you create a new feature branch for your specific task. Third, you write your code, staging and committing your changes. Fourth, you push that branch to GitHub. Fifth, you open a pull request for your team to review. And sixth, once approved, it's merged, and you delete the branch to keep things perfectly tidy. Now, to make that workflow reliable and scalable, there are a few strict, non-negotiable best practices you absolutely must follow. You should commit your changes frequently so you always have granular restore points. Keep your branches really small and focused on a single task. Always protect your main branch. And critically, this is a big one, never commit secrets like passwords or API keys. You use a special file called .gitignore to tell Git to completely ignore sensitive files. On the flip side, you definitely want to avoid these common beginner mistakes. Forgetting to pull updates before you try pushing your own code, that will almost always cause errors. Also, Git is not meant for huge files like high-res videos. It's meant for text and code. Never work directly on the main branch. Always use a feature branch. And please avoid writing vague commit messages. A message that just says fixed bug is practically useless to your team compared to something clear like fix login button alignment. As we wrap up this explainer, I want to leave you with this final practical challenge. We've seen how Git and GitHub provide a brilliant, structured way to track every single change and collaborate seamlessly. So how would you implement version control in your very next project to finally escape the final_final trap? Honestly, the absolute best way to learn these tools is to just dive in and start practicing them immediately. Thanks for joining me on this explainer, and happy coding.